Hey everybody, today we are going to dive into the canvas and specifically focus on using values. Let's start with just the basic concepts here of just like brights and darks. The first thing that I'm going to do is we'll start on the canvas with just like a pure white blob raster layer. I'm going to do a raster layer. I'm just going to crop that real quick to the bounding box. So we've got a nice clean layer. That's just, white. What I'm going to do next is I'm going to draw kind of a blob in the middle. I'm going to do something that's a little bit more gray. I don't want it to be purely black, and I'll explain why. But I'm going to do some grays in the middle. We're going to do a pirate on a white background. If we do low denoising strengths, even 0.5, what we're going to see is it's going to stick very, very closely to this kind of like blob that we have. It's not really going to give it enough juice. You can see what got transformed. It didn't really transform much. If we start getting up to like 0.75, we'll see more of that. Unhide this so that we can see it, but not enough. Still not enough. When we get up to 0.95, when you're using this to transform colors and you've got an existing composition, 0.95 is going to do a lot. It's going to move things quite a bit. But the beauty of having really stark contrast, very, very bright whites and very dark or at least significantly colored inputs, is that you're creating a little bit of a structural difference that has to be transformed. So if we do this at 0.95, what we're going to see is that we have biased where stuff is, where there's like content, but we've not constrained it to the exact shape or structure. We're basically like pushing it more towards where things will be. And you can use this technique for a lot of different use cases. You can use this in a couple of interesting ways. The thing to recognize here is when we start this generation process, we're using kind of like noise, right? And it's kind of like white, fuzzy, Gaussian noise. It looks like a broken TV, right? When you use image to image at a very, very high denoising strength, like 0.95, you're taking that noise and you're kind of nudging all of the pixels towards brighter or darker versions of that noise. That's kind of what happens at the really, really high denoising strength. And when you do that, you're biasing the output to have content or contrast that matches that. Now, it's not obviously like constricted at that high denoising strength to just those areas, but this is like a useful technique for a number of use cases. You can put silhouettes on a white background. You can do icons using this technique. So we discard our pirate here and we want to do like a logo or something like that. We can do a vector logo emoji style smiling monkey. Well, let's do that. And what we're doing is we're kind of saying we want that to be in the middle of the screen, right? And this just gives us a really nice clean output that we can go use and take out. Now that we've got this, we've got a really easy thing that we can use to select the object and kind of pop that out and have a transparent output that we can save out and use anywhere that we want to. So we'll apply that. You can see kind of where the bias was, right? We biased it towards the center. We'll get rid of that, maybe clean it up a little bit. And then we've got our transparent monkey, getting rid of the white, going in and doing some of those details. You can pop this out to a transparent PNG and then take it wherever you need to go. This is kind of like the base technique, right? Of I just want something somewhere and I'm going to do really high denoising strength and do really high contrast. Now, if this is not a significant contrast, if we've got, let's just do this, we're just going to do something like this. We'll go back to our pirate on a white background and I'll do my concept art again. So we don't have that very clear distinction. I'll turn my seed onto random just so we can have that. And I'll do 3 variations. I anticipate we're going to see pretty significant shifts in the composition and structure. And that's primarily because we're not telling it anything. We're not giving it any guidance. We're kind of like nudging it in all directions at the same time. There's no contrast in the values. And that's the key takeaway here, really, is that when you're doing denoising in this part of the denoising process, big shifts in contrast are ultimately what can carry through to the output. This is where bright brights and dark darks can guide the structure of what you are outputting, but where the color itself doesn't necessarily matter as much. So this is kind of like maybe exploring another area of this denoising strength relationship where we're really finding this kind of like structural piece. If I were to create a white on the left, but content on the right, and we generate 3, but we're biasing it towards having more of the subject matter on the right, or at least like more of the stuff there, although we can see that this pirate still kind of crept out. So we've got a pirate there, and then this pirate here. You can see how that shift really kind of pushes it over to the right-hand side. It's an interesting tool. It's an important amount of understanding like what it does. So I've got a quick kind of values sketch of this insectoid overlord that has this kind of like dagger in his hands. A lot of tiny detail here. One of the techniques that a lot of like concept artists do when they're going through the process is they do quick values to understand where the values are and how the overall composition is influenced by lights and darks. This is kind of a cool technique to use because you can actually take those values, the rough colors and the values sketch that you put together, and feed that in with the ability to kind of like transform the colors but respect the values. So we've got this raster layer. I'm going to copy it to a control. We'll do kind of like the line art edge detection, get the kind of like lines out. We'll apply that. And then we are going to change our prompt. We've got an insectoid overlord holding a dagger, chitin, dark radiating chitin. So I'm going to do this at different denoising strengths so we can see where the color starts to pop in, right? So if we do this at 1, if we do 1 at 0.5, and then 1 at 0.75, 1 at 0.85, and then 1 at 0.95. What we're going to see is we're going to see a little bit of color and then increasingly more and more and more color, whereas the values themselves will still kind of persist even into those higher ranges. And that's where you get some like really useful mechanics here when you're playing around with the higher denoising strengths. So this was our 0.5. We got our 0.75, and then 0.85, and then 0.95. And you can see where you get more and more color in and how those values persist even in those colored versions. So this one's got color. This is our, I think, our 0.85. It's got color here on the sides. It's got color here in the character in the middle. But if we look at where the color was injected, it's only in those areas that weren't very stark white. It's where that initial image had some content, right? Everywhere else kind of still is pretty bright in the background. And this is where you're really wanting to make sure that a certain shape is preserved or certain kind of like barrier line is maintained. Having this type of stark contrast really helps in that denoising process, because even at 0.95, most of those values persist up into the generation. Obviously, the higher you get, the more that small variations in values are not maintained. So let's look at like areas where it didn't maintain the values. This coloring right here, the before and the after, you can see that it got a lot darker. It overrode the values that were in that initial sketch because it's injecting its understanding of shadows and light and how that would actually play out. And so that's why it gets a little bit shadowed there. It does a highlight here on the right. The left-hand side is more shadowed. It's going to override certain things to make the image coherent. We want it to do that for us, but what it's not able to do is really override this white area as much. Let's do something that's maybe a little bit more like on the rails. We'll cover this up with white, and we'll make this a tower of glass on a cliff looking over the sea. This is going to bias it towards there being some sort of tower over here. It's going to give us a little bit of structure. Now we've got some control and compositional guidance that pulls this out. That's kind of cool, like interesting effect. It looks kind of like a tilt shift kind of effect, but you get the idea of like the darker the areas in this tool, the more you're kind of like biasing it towards something being there versus lighter areas or background colors off in the distance. The reason why this is incredibly important to understand is because this is true whether you're trying to use it like this as a tool or whether you're just using an initial image, right? whatever you're using, when you get into this range of the denoising strength, you're giving more and more control over to the model to reinterpret the content. But at these higher strengths, that's still going to be biased towards these values, right? You're still guiding it towards those things. And if we were to take this image, for example, reimagine at 0.5 and 0.75 and then 0.95, what we will see is the thing that's maintained the most across all of these is these values, even though at higher strengths, we're getting further and further away from the initial structure. The values are maintained. This is where the cliff is. This is where it's going off into the distance. But the structure can change pretty dramatically, or the details can change because you're giving a lot of that freedom over. Now, this is just kind of a cool thing. I like this. I don't know what it is, but I'm going to save it anyways to my gallery. One thing that I want to show, which is a cool technique, I'm going to convert this to a control layer. And I'm going to use the Union Pro model, but the filter type that I'm going to use is going to be a normal map. Now, what normal maps do is they kind of look at the image and find lighting. It's looking at it and trying to figure out how light is reflecting off of things inside of this. Now we've got the normals of this image that we just created. Maybe I want to say a tower of cube-like rocks on a cliff overlooking the sea. And we're going to use this normal in the multi-guidance detection. It pulled in the lighting from that glass, and so that's why we're seeing the lighting in here actually work out that way. But this didn't have an initial image. Remember, this is just the control layer itself. And what it's doing is it's looking at the lighting. It's looking at the scene, and it was able to pull this out without us having raster layer, without us having any kind of like a bias towards the colors. It's purely basing this on the control image itself. So the normals are really interesting because they help you guide that lighting. You can pull in normals from other tools that you're using. It's an interesting way to guide this. It's really fun to use that as a tool. We'll go back to this one and we'll just do this with the same idea. We'll go to multi-guidance. First, let me duplicate this. We'll filter one with canny, filter the other with normal. You can do this with depth. You can do this with anything. You can combine multiple controls together, merge that down, and we're going to say ice cubes sitting on a cliff side in Ireland. Multi-guidance detection is our model. Despite us having kind of like merged those two filter images together, it's able to kind of piece out what it's looking at, right? It's using both of those things, the lines as well as the underlying like normals to guide that generation. So we get this, which is pretty cool. You can kind of merge different control layers together. And the Union Pro model, it's a really cool emergent capability of this model, is able to kind of use both of them together in generating this output. So that's kind of a cool technique. Hopefully that was helpful. Before we close, last most important piece, make sure to like and subscribe on YouTube, everybody. Your support is valued. Call it there, and thank everybody for coming. We'll see you next time. Bye.